Hey guys, in this section we're going to look at our next little bit of information, and this is where we get a little bit more math thrown into our lessons. Again, we're really going to actually be looking at some math and some numbers in this one, so just be ready for that. So we're going to be looking at making inferences from sample surveys. So first we're going to look at, there's two different types of statistics that we generally talk about or look at. And the first is descriptive statistics. So this involves the organization, my pen works again, summarization and display of data. So those descriptive statistics, which makes sense with the word, they describe the data and the statistics that we're looking at, either in a graph or a chart or actually using numbers. It's some way to describe the data. So then inferential statistics is using a sample to draw conclusions about the populations. Because as we've talked before, it's really quite impossible to get data and information about an entire population usually. So we have to take those samples and get the data and information from that. So those are going to be our inferential statistics, because we're inferring, we're taking what we find and kind of making it fit the rest of our information. Okay, so one thing we're going to be looking at here is the population mean. So remember that when we're finding the mean, we're taking all of our data sets and adding them together and then dividing them by the number of data pieces that we have. So when we're finding the population mean, we can use the sample mean to get us there. Okay, so go ahead and give yourself a couple of words about that for the population mean. But since we don't have all of our population data, because that's just not realistic, we can take our sample data and get what we need to do. For example, here I have the numbers of friends for a random sample of 40 teen users of a social networking website are shown in the table. Estimate the population mean. So in order to do that, I'm going to actually give you the fancy math write out if you want to look at it. It doesn't really matter to me much, but I need you to be able to recognize that that's what it's talking about. So I've got X mean, which is my sample mean, is equal to, this big word is sigma. That's the sum of all my X values, right? All of my number of friends divided by N, which is how many of them there are. So there's just my fancy math way of writing it. So once I do that, I end up with 11,966 divided by 40, which is approximately 299.15. So when we're writing this data out, this data, remember, is about the number of friends that we have. We can't have partial friends. So in order to estimate this, we would say that the population mean is about 299 friends, because we can't have decimals of friends. That just would be really weird. Okay, so now let's keep rolling. So now we're going to be looking, this is actually example number 2 in your book if you're following along. So a student newspaper wants to predict the winner of a city's mayoral election. 2 candidates, A and B, are running for office. 8 staff members conduct surveys of randomly selected residents. So based on our last lesson, right, that's a big important piece, is randomly selected, which means this is probably pretty valid data. The residents are asked whether they will vote for candidate A. So then we would say that if a no, they would be voting for candidate B, since there's only those 2 possibilities. The results are shown in the table. Based on the results of the first 2 sample surveys, do you think candidate A will win the election? So let's look at our first 2. Okay, so based on the first 2, the things that I notice is my sample size is not very big. So I don't know how much I would put into that data, right? Just because those are really little teeny sample spaces. So then I would also see the percentage of votes for candidate A are 40% and 33.3%. And in order to win, we know you have to have more than 50% of the vote. So I would say based on those 2 surveys that probably candidate A will not win the election. Okay, so that would be my answer to A. So then B, based on the results of the table, do you think that candidate A will win the election? So now we're looking at the whole table. So the thing I notice that my sample size continues to go up as I move down my table. Okay, the other thing I notice is that as I move up the table, right, as our sample size gets bigger, the closer to the real population value we would probably end up with. So that's why we want to get large sample sizes. So I see that as we get larger and larger, we get closer, like we're in the upper 50s here. So to me, that would tell me that, yep, if we were to actually do this election, that candidate A would win because they would get more than half of the results. And I can say that because my values, as I go up, seem to kind of get close to this 58 or 59%. Okay, so now margin of error. This is where that like actual math is really going to come into play. Okay, so the margin of error gives us a limit on how much the responses would kind of change based on the population. Okay, so that's what the margin of error is. And you'll see this as always a like, here's our value, our data, plus or minus some percentage. Okay, so we're going to say like 78% plus or minus 2%, which means it could be anywhere from 76 to 80. Okay, and we'll see that in just a minute. So my formula for the margin of error, and this is something you really do need to have, is a plus or minus, remember, because it could go up and it could go down, 1 over the square root of n. So n, remember, is the number of values that we have, or the number of survey takers, or the number of data points that we have. So in a survey of 2014 people in the US, 55% said that television was their main source of news. What is the margin of error? So in order to find that, I just replace that square root of n with the square root of 2014. And I go ahead and I put that in my calculator. And I figure that out. Which I don't know where I even got that example from. Okay, so you would go ahead and do that. And then you would figure that out. So let's look at the calculator. Let me pull up my calculator right here. So I've got 1 divided by, and I don't use this calculator very often, so I want to make sure the square root, oh, nope, clear. Oh, it won't even clear. Okay, 1 divided by 2014, the square root of that equals. So we can see, based on my calculator here, that my margin of error, and remember that this is just a decimal, so to get to a percentage, I would have to move my decimal over 2 places, so it would be plus or minus that 2%. Okay, so give an interval that is likely to contain the exact percentage. So when I do that, I would take my 55%. Uh-oh, did I break it again? I broke it again. I broke it again. So I would have my 55%, and then I would add to it that percentage that I found, and I would subtract from it the percentage that I found as well. So that would give us that interval that would contain it. Now it's working. Okay. So now we're going to analyze some estimated population parameters, right? That's a whole lot of words. So a national polling company claims that 34% of U.S. adults say, that should say, it's not, mathematics is the most valuable school subject in their lives. You survey a random sample of 50 adults. What can you conclude about the accuracy of the claim that the population proportion is 0.34 when 15 adults in your survey say math is the most valuable? So that's step A. Okay, so let's look down here. So the first thing we're going to do is we're going to generate 50 random numbers using a calculator, using a number generator, something like that, from 0 to 99 for each sample, because that's looking at percentage, right? Since we're looking at percentage, 0 to 99 would kind of be our percentages. So 1 through 34 would say that math is the most important. And we're saying that 0 through 34 since we're saying that 34%, oh no, now I made it really mad, say that math is the most important. Okay, so that's why we're looking at these numbers from 0 to 34. So in my sample, that's where I got all of these values from. Okay, that's where these values all came from, is just that random generator and laying them out, 50 different numbers. Okay, so that 15 out of 50, and remember 15 because 15 adults say that it is, gives me that sample proportion of 0.3, which falls right here in my line. So this happened in 7 out of the 80 samples. Okay, so therefore, since it actually happened quite a few times, it happened fairly often actually, I would conclude that the company's claim is probably accurate. So that's what we could say. We could say, therefore, it's probably true that it happens and the claim is probably accurate. So for part B, what can you conclude about the accuracy when 25 adults in my survey say math is the most valuable? So again, I would do my 25 out of 50 is that proportion of 0.5. So in my simulation, that only happened once. So one time is really not that many times. So that I would say it's not very likely. It's not accurate, just based on my samples. Okay. So then part C says, assume that the true population proportion is 0.34. Estimate the variation among the sample proportions using sample size of 50. So in order to do that, I want to look at my distribution. So my distribution's approximately normal. Now go back to what normal distribution looks like. So in normal distribution, 95% of my sample proportions are within 2 standard deviations. So excluding my 2 lowest and my 2 greatest, gives me about 95%, right? Because each one of them was considered was 1 out of 50, right? So that gives me about 95% of my data. So then my 76 proportions are from 0.2 to 0.48. So 95% of the time, a proportion would lie in that interval from 0.2 to 0.48. Okay, this is not something you're gonna have to be epically good at. So now the really big thing I want you to focus on for this section in this lesson is really that margin of error, because that is going to be something that matters a lot. So that's where I want you to focus. So again, I am looking for your homework. It's over here in my pile of stuff. I'm going to assign this in big ideas as well. So you do have that ability to check your answer and make sure that you're correct while you're working through this. If you want to do it on paper, that is fine with me too. So as always, reach out whenever you get stuck or have questions on anything. Thanks, guys.